In this lesson, we are going to talk about domain of functions. We previously talked about domain of a function given the graph of a function, and now we are going to talk about it given the formula for the function. Okay, my icon is a lion, and I'll explain that as we go through. Our objectives today are to understand domain and to be able to find the domain of a function. So with domain, there's a scene in The Lion King that I always think of when we go over domain. Mufasa, who is the king, says to his son Simba as they're looking out, I think they're up on a big rock, and Mufasa says, "Everything the light touches is our kingdom." Another way of putting that is wherever the light touches is their domain. It's where they are allowed to go. It's where they rule and reign. But anyway, just think of it as it's where they are allowed to go. So functions, when it comes to domain of a function, it's the x values where the function is allowed to go. Okay, it's the domain of the function. It's where it's allowed to be in terms of the x values or the input. Another way of thinking about it is it's the x values that you can actually plug in and get a y value or get an output. Okay, so for a lot of functions, like linear functions, quadratic functions, you can plug in anything. But there are some functions that have domain restrictions, and those are square root functions. Because of the square root, we need whatever is under the root to be 0 or positive, and rational functions. And rational functions are where we have a polynomial on the top and a polynomial on the bottom. And basically with rational functions, we're concerned with denominators, okay, because we can't divide by 0. Just a quick recall, interval notation. So when we're writing domain, we'll be writing it in interval notation. If an endpoint is included in the domain, it gets a bracket when we're using interval notation. And if an endpoint is not included, it gets a parentheses. Okay? So example 1, find the domain of the function, write your answer in interval notation. So part A, we have f of x is equal to 2x plus 1. Are there any restrictions on that? We don't have square roots. We don't have denominators. You can plug in anything. You can plug in -1,000,000. You can plug in 500. You can plug in 0. You can plug in 1. And you would be able to get an output. So when it's all real numbers, we write that as -infinity to infinity. So the biggest number, I guess smallest number, or the largest negative number to the biggest positive number possible. Okay. Part B, x squared, f of x equals x squared minus 3. Again, we can plug in any number and square it. There's no restrictions, there's no square roots or denominators. So again, we have -infinity to infinity. Okay. So going into the function types that do have restrictions, square root functions. So we cannot take the square root of a negative number and get a real number. I know we talked about square roots of negative numbers, but when we're dealing with the xy plane, when we're dealing with graphing functions, we're dealing with real numbers in this class. Okay? So that means that whatever is under the square root must be 0 or positive. So what that means is if we have stuff under the square root, that this stuff can be 0 or positive, which a way to write that as an inequality is greater than or equal to 0. So for these functions, when we're asked to find the domain, we'll take whatever's under the square root and we'll set it greater than or equal to 0 to find out our x values that we're allowed to plug in. Okay, so example 2, find the domain of the function, write your answer in interval notation. So here we have the square root of x. X can be 0 or positive, so one way to write this is x is greater than or equal to 0. There's nothing to solve here, but we do need to write it in interval notation. And I like to use number lines to write in interval notation. So here's 0. 0 is included. So I'm going to put a closed circle there. And anything that's bigger. So this would point to the right. Okay, you could also put a bracket and point to the right. I think that's how MyLab does it. In interval notation, our smallest x value is 0 and it's included. It's okay to take the square root of 0. It's just 0. And then this goes all the way up to positive infinity. So my domain here is 0 with a bracket up to infinity. Remember that this must be written smallest to biggest. Part B, g of x is equal to the square root of 5 minus x. So again, we have to be careful. Whatever we plug in for x must make 5 minus x positive. So the way to see what values we can plug in is to take what's under the square root and set it greater than or equal to 0. And now we'll solve the inequality. So I'll subtract 5 from both sides. We have -x greater than or equal to -5. Solving for x, divide both sides by -1. Remember, when you divide by a negative, you change the inequality sign. And we get that x is less than or equal to 5. So we can plug in 5 or anything smaller. You may be able to write interval notation from here, and that's okay. but I'm going to write it on a number line. Okay, so 5, and we can include 5, and any values less than. So when we write this in interval notation, the smallest value is negative infinity, the largest value is 5, and it gets a bracket. So this is our domain. Domain of rational functions, so we cannot divide by 0. So whatever is in the denominator cannot be 0. So if there are any values that make the denominator 0, we have to exclude those from the domain. Okay. So first, find the domain of the function, write your answer in interval notation. So this should say f of x or g of x. Let me write that. Okay, x plus 2 over x minus 7. Now 0 is okay in the numerator. So 0 over any number is just 0, and that's because 0 times a number is equal to 0. But 0 in the denominator is not okay, because what can we multiply 0 by and get a number? Nothing. So the numerator can be negative 2, is what I'm saying. Okay. In our case, the denominator, in order to find out what makes the denominator 0, you can set it equal to 0. Okay, and this gives us x equals 7. So x can be anything else except for 7. So when we put this on a number line, here's what it would look like. Let me put some values for reference. Okay, we can't have 7, so I'm going to do an open circle, but it can be anything else. Okay, so it can be like negative 10, it can be negative 100, it can be 6.9999, 7.11111, but it cannot be 7. Okay, so we write this in interval notation. So we go from negative infinity to 7, and 7 gets a parenthesis because it's not included. You cannot plug in 7, so this is where we get the parenthesis. And then we go from 7 to infinity, and we join these two intervals with the u for union. Okay, so negative infinity all the way up to 7, and then past 7 to infinity. Next, find the domain of the function. Write your answer in interval notation. Let's call this one g of x. Okay, so we need to figure out where the denominator equals 0. So we set the denominator equal to 0. And guess what? We have an x squared. So we're going to factor and solve. We're looking for two numbers that multiply to negative 3 and add to negative 2. So we have x minus 3, x plus 1 equals 0. If I set both of these equal to 0, I get 3 and negative 1. So again, x can be anything except negative 1 and 3. So when we plot this, okay, when I draw a number line here, it's represent all of the x values that we're allowed to have. Okay, it just gives a visual of what we're allowed to plug in. So we can't plug in 1, so I'm going to put an open circle there. We can't plug in 3. But again, we can plug in like 2.9999, 3.00001, okay, and it can be anything except for these values. So we have one interval here from negative infinity to negative 1, another interval here from negative 1 to 3, and another from 3 to infinity. So as our final answer, we would write all these out together. Negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. Okay. So this is how we say in interval notation anything except negative 1 and 3. Thank you for watching. If you have any questions, feel free to reach out to me.